Hey, what's up? It's your old pal, Mr. Cook, and we're going to work on the group work for Unit 3, Part 2. So the first video will be the first page, and then we'll go through the second page and maybe a couple extra word problems on another video. Okay, so first off, we want to solve these exponential expressions. We want to give exact solutions, so you actually won't need your calculator like at all for this first half of the exercises. So for these problems, we want to find the same base, because if we have two exponents equal, we want their same bases. So we can use this nice little property called the one-to-one property, which says that if we have two exponents with the same base and they're equal, then that means that we can set the powers equal to each other. But we need to get to the same base to be able to do that. So that's why we can manipulate these a little bit to get to that, get that desired effect. Okay, so the first thing that I'm going to do is change this 25 into a base 5 exponent. So 25 is 5 squared, so I'm just going to rewrite it as 5x minus 6 equals, and then instead of 25 I write 5 squared to the power of 2x plus 3. Okay, and then from here I'm going to use another exponent property for this one, which goes something like this. If I have an exponent and I raise it to a power, then it's the same as taking that exponent and multiplying the two powers together. So I'm going to take this 2 and this 2x plus 3, and I'm going to multiply them together. So I get 5 to the power of x minus 6 is equal to 5 to the power of... And then when I multiply these two together, remember that I've got to distribute. So 2 times 2x is 4x, 2 times 3 is 6. Now that I have the same bases on these equal exponents, I can set the powers equal to each other. So x minus 6 is equal to 4x plus 6. And then I can just solve it. So subtracting x from both sides, I get negative 6 is equal to 3x plus 6. Subtracting 6 from both sides, I get negative 12 is equal to 3x. And then dividing by 3, I get x is equal to negative 4. And the nice thing is that for these exponent problems, like number 1, number 2, and number 3, there won't be any extraneous solutions, because those are only the log problems. So I don't really need to check those out. So this is my solution. We're good to go. Number 2, you do it the same way. So 36, we need that to have a base of 6. So the easiest way to do that is turn 36 into 6 squared. So we get 6 to the power of x plus 6 equals 6 squared to the power of x squared. And then, the same rules apply for that as well. 6 to the power of x plus 6 is equal to 6 to the power of 2x squared. The bases are the same, so I can set the powers equal. X plus 6 equals 2x squared. Then this is a quadratic because it has an x squared on it, so I'm going to zero out one side, so I'm going to subtract both of these away. So I get 0 on one side is equal to 2x squared, and then minus x, and then minus 6. And then I'm going to try to factor this. So let's see, numbers that multiply together to be, so it's 2 times negative 6, so multiply together to be negative 12, and then add together to be negative 1. Those two numbers would be negative 4 and positive 3, so this does factor. So I get 0 is equal to 2x minus 4, 2x plus 3, and then divide out the common factor. So I get 0 is equal to x minus 2 times 2x plus 3. And then if x minus 2 equals 0, that means that x has to be equal to 2. And if 2x plus 3 equals 0, that means x has to be equal to negative 3 halves. So these are my two solutions. And again, there won't be any extraneous solutions, so you're good to go with this one. But don't take my word for it. You can plug it back in and solve and all that kind of fun stuff too. Number 3. So now we've gone away from an exponent equals another exponent to exponent equals a number. So in this case, what we need to do is isolate the exponent and then convert it to a log. So I'll show you why this is different from the previous problems in a second. So we want to get the exponent by itself. We isolate the exponent. So we got to add 6 to both sides. So we end up with 5 to the power of 2x plus 2 is equal to 14 plus 6, which is 20. Now notice that this is an exponent equals a number. These ones have been exponents equal to exponents, so that's why we treat them this way, and we use the one-to-one property for this one. We're just going to use the regular old conversion from an exponent into a log. Because remember, that's how you can solve for exponent powers, because exponents and logs are inverse functions of each other. So we use the power, we use that property that goes something like this. If I have an exponent to the power of y, and that ends up equaling x, then I can rewrite it to solve for y in the following way. Log with a base of a of x equals y. So I can solve for the exponent. So anytime I need to solve for the exponent, I need to convert from exponent to log, and that'll come in handy when we work on the word problems as well. Anyways, so what we're going to do here is convert this to a logarithm. So it's going to be a log with a base of 5 of the number 20 is equal to 2x plus 2. And since we want exact solutions, we don't want to figure out what that is in our calculator, but it's just some number, okay? So if it's just some number, how do I get x by itself on this side? Well, I need to subtract 2, and I also need to divide by 2. So I end up with log base 5 of 20 minus 2, so whatever that number is, minus 2, over 2, and that's equal to x. So this is going to be our answer. And we can, we don't need to double check this in here because there won't be any extraneous solutions. So this is just going to be the answer that we need for this one. No need to use your calculator, just leave it alone. And it actually saves some time also. So that's kind of a bonus on there too. All right, now we start up with the logs, and we do need to check for extraneous solutions here. So natural log of 2x minus 5 equals 3. Remember that natural log, when it says ln, that really just means a log with a base of the number e, Euler's number, the natural number. So that's log base e of 2x minus 5 equals 3. And when we have a log isolated by itself equal to a number, we're going to do the same thing that we did for exponent equals a number, and that's just convert it. So we go from log to exponent in this case. So it's going to be e to the power of 3 is equal to 2x minus 5. And then we solve for x. So we add 5 to both sides. E to the third plus 5 equals 2x. And then divide by 2. So x is equal to e to the third power plus 5 over 2. There's our solutions. All right, and then, we got to double check it just to make sure it's not extraneous. So, you find out what that number is. E to the power of 3, and then plus 5. And then divide that by 2, and then just plug it back in here. So 2 times that number minus 5, and then that's equal to 20. So yeah, natural log of 20, you can do that, so that'll work out. Just make sure that whatever you plug in here doesn't result in a negative number or 0. It has to be positive. Every single time it has to be positive. All right, number 5, 6, 7, 8, and 9 are all kind of handled the same way. I'm going to do the first step for each of these because I'll show you that it's the same first step for each of them, but from there it kind of goes off in 2 different directions. So I'll show you that the first step's the same for all of these. For number 5 and number 6, number 7, number 8, and number 9. So I have a log, and they're subtracting, so that turns into division. So I'm condensing each of the logs into a single log for all these properties, and I'm sorry, not properties, for all these problems first. So log base 3 of 4x minus log base 3 of 28 turns into log with a base of 3 of, and then 4x goes in the numerator, 28 goes in the denominator, and that equals 0. So we've condensed it into a single log on this problem. We're going to do the same thing for number 6. We have 2 logs and they're adding, so that turns to multiplication. So this turns into log of x times x plus 1 equals log of 12. All right, so we've condensed this one into a single log. We're going to do the same thing for number 7, condense these 2 logs because they're adding into a single log. We get log base 2 of x times x minus 7, and then that equals 3. For number 8, condense these 2 logs together using subtraction. We get log base 2 of x squared over x minus 2 equals 3. And then for number 9, we have 2 logs that are subtracting, so we get log base a of 2x plus 5 in the top, and then x in the bottom, equals log base a of x minus 2. All right, so that first step is the same for all 5 of those problems. But from here, it gets a little bit different. Okay, so notice that your logs in each case are equal to different things. This log is equal to a number, this log is equal to another log, this log is equal to a number, this log is equal to a number, and this log is equal to another log. This is what separates the 2 different ways that I'm going to go. So for this one, I'm going to, if it has a log equals a number, like number 5, number 7, and number 8, I'm going to convert it from a log into an exponent. The same reason, the same way that I did over here, where I had a log equals a number and I convert it to an exponent. Same thing is true here. It just looks a little bit more complicated. But it's the same process. We set this up as an exponent. 3 to the power of 0 is equal to 4x over 28. And then for number 7, 2 to the power of 3 is equal to x times x minus 7. And then for this one, 2 to the power of 3 is equal to x squared over x minus 2. And then you just solve them, so like 3 to the 0 power is 1, so 1 equals 4x over 28. So multiply both sides by 28, you get 28 equals 4x, divide by 4, x equals 7. And then make sure to always check for extraneous solutions. So we plug in 7 for the lone x value here. 4 times 7 is 28, and we can take log base 3 of 28. So that one checks out okay. Now for number 7, 2 to the third power is 8, and then x distributed in there gives us x squared minus 7x. So now this is a quadratic because of that x squared right there, so I'm going to subtract 8 to get a 0 on one side, so 0 equals x squared minus 7x minus 8. This factors, so numbers that multiply together would be negative 8, add together would be negative 7, that's going to be negative 8 and positive 1. And then we get our answers for x. X is equal to 8 and also negative 1. Now let's check for extraneous solutions. For 8, if we plug it in, log base 2 of 8 works out, and then 8 minus 7 is positive, so they're both positive, so we're good to go. So that one checks out. Now let's check out negative 1. If I plug in negative 1, we have log base 2 of negative 1. Automatically, that's the log of a negative, so we can't do that one. So this is an extraneous solution. All right, next, we're going to do number 6. So, number 8. So we convert that into a log, from log to an exponent, and then 2 to the third is 8. 8 is equal to x squared over x minus 2. Now here's a simple way to solve a problem when you have x in the denominator. Just turn the other value that it's equal to into a fraction and then cross multiply. Okay, so we get 8 times x minus 2, and then 1 times x, so equals 1 times x squared. There we go. Distributing in the 8, we get 8x minus 16 is equal to x squared. And then since this is a quadratic, I want to zero out one side. I'm going to move all this stuff over, so I get 0 is equal to x squared minus 8x plus 16. And then this factors. Numbers that multiply together to be 16, add together to be negative 8. That's going to be negative 4 and negative 4. So that means that my lone solution is going to be x is equal to positive 4. All right, now let's check and see if it's extraneous or not. So we take 4, plug it back in here. 4 squared is positive, 4 minus 2 is positive, so both of them check out, so this works out. All right, now let's see how to do number 6 and number 9. Now, when I have a log equal to another log, as long as the bases are the same, and remember that when it says log only, that means log base 10, so they have the same base here, 10. That means that I can just set the parts that are in the log equal to each other. So this becomes x times x plus 1 is equal to 12. And then, we just solve it from there. So x distributed in there is x squared plus x equals 12. 0 out one side, so we subtract 12 from both sides. X squared plus x minus 12 equals 0. Factor it. Numbers that multiply together to be negative 12, add together to be 1. That's going to be plus 4 and negative 3. And then solve for x. So this one gives me negative 4. This one gives me positive 3. So those are my two solutions. Now let's check and see if we have extraneous solutions or not. If I plug in negative 4, oops, that already automatically gives me a negative, so that's extraneous, not going to work. Let's try 3. Log of 3 works, that's positive, and then 3 plus 1 is 4, so that's positive also. So 3 works, negative 4 does not. 9, same thing, the logs are equal to each other, so we can just kind of cancel them out, and we end up with 2x plus 5 over x is equal to x minus 2. So just like I said before, if x is in the denominator, just make the other one a fraction and cross multiply, and you can solve it. So 2x plus 5 times 1 is just simply 2x plus 5. And then x times x minus 2 is x squared minus 2x. It's a quadratic, so I got to zero out one side. So we get x squared, and then negative 2x minus 2x is negative 4x. And then subtract the 5 out. All right, and then this factors. So let's see, x minus 5, x plus 1. Yeah. And that gives you my 2x values. X is equal to 5, and x equals negative 1. All right, let's check for extraneous solutions. If I plug in 5 times 2 is 10, 10 plus 5 is 15, and then 5 is positive, so positive, positive, and then 5 minus 2 is positive. So this one works out. Let's check negative 2. Negative 2 plus 5 is 3, that's positive. And then, oops, log base a of negative 1, can't do that, so this is going to be extraneous. All right, number 10, we did this problem in the notes. It's kind of like a challenge problem. All you got to do is just substitute y in for e to the x, and then it makes it a lot easier. Because e to the 2x is really the same as saying e to the x squared. So this first thing just becomes y squared because e to the x is y, so we can just replace it in there. Minus 5 times e to the x, which is y, minus 6 equals 0. And then this is just a simple quadratic at this point, so we factor it and solve it. Factoring this, we get, let's see here, y minus 6, y plus 1 equals 0. And then solving, we get y is equal to 6 and also negative 1. Now, we need to solve for the x value, so since these y values are equal to e to the x, I just take each of them, 6 and also negative 1, and set it equal to e to the x and solve. So for this one, it's an exponent equal to a number, so I change it into a log. So I have log base e of 6 is equal to x, and log base e of 6 is really just natural log of 6. So that's my one x value there. And then if I try to do that same thing over here, tragedy happens. We get log base e of -1, and unfortunately we cannot take the log with a positive base and find a negative number. So this is impossible to do. So we only have one solution, and that's natural log of 6. So that's the front page. A lot of work here. Make sure that you get to your class on time and you know, start on that test as soon as you get in there, because these can take some work. They're not really hard. It's just that, you know, showing your work and doing all that stuff kind of adds on some time. So make sure you work on that. All right, that's it. Let's move on to the second page and onto a second video.